All right. So just a quick remark on how the path of a projectile looks like. So it is often very useful to know path of a particle because as we'll see in the next videos, path bears a lot of information that we can use to describe the motion. So going back to projectile, I have my projectile. It should here, something like this, and the motion follows. We want to see what is the equation of this path, essentially y as a function of x. How can we describe this equation? So that is relatively easy, just as a reminder. We had x equals x naught plus v naught xt, and y was y naught plus v naught yt minus 1/2 gt squared. I have two equations for x and y. Both of these are functions of time. So what I need to do is eliminate time between these two equations, essentially calculate time from one equation, substituting in the other to find equation of y, for instance, with respect to x. So let's go ahead and do that. So from the top one, I can write x minus x naught equals v naught xt, or t equals x minus x naught over v naught x. So that is the expression. If I know initial x velocity and the location along the x, I can calculate how much time has passed. And then I plug that into the second equation, y equals y naught plus v naught yt, x minus x naught v naught x minus 1/2 gt squared. V naught x squared. And that is an ugly yet practical equation for y as a function of x. Something to note here, I have some x squared on this part, a bunch of x's, and a constant value. So essentially y is some constant, a naught, plus another constant, a 1x, plus another constant, a 2x squared. So this one you can calculate what a naught, a1, and a2 are. But at the end of the day, the equation of a projectile, you may have known this already, is a quadratic or parabolic equation. So the curve the projectile takes is a parabola or a quadratic curve. So useful to know that it is second order. A few things obvious, but let me maybe write them down. As you launch a projectile upward, the projectile goes up with some component of upward velocity, reaches a maximum height, and comes back down. And that is the case if the entire motion is in vertical direction. Here you have essentially a parabola that is collapsed in one direction. The particle goes up, reaches a maximum height, velocity becomes 0, and continues coming down and increasing velocity in the negative direction. Yeah, I don't really have anything else to say other than being explicit about if you have velocity given a vector, for instance, its direction and magnitude, you know the speed and the direction. We can calculate Vx and Vy is norm of V cosine of that angle, and Vy is norm of V sine of that angle. And I think that is all we have. So we can, when we are given a problem with projectile motion, we can calculate using the information. For instance, we can calculate the initial velocities, and from initial velocities we can calculate the positions over time, because we always know gravity is constant in y direction. We can calculate maximum height if it's set velocity in y direction to be 0, and so on. There are quite a bit of variety. Somebody can formulate a projectile motion, but all of them are based on just the simple equations of constant acceleration along y and constant but 0 acceleration along x. So we'll see a lot of examples in class. So I will stop here and I'll see you in the next videos.